Thank you, Morag. So this wee bit is going to be about computer systems. So because systems is very much kind of fact-based knowledge, it's probably the most straightforward area to actually generate quick, easy to access, short response questions, starters, formative assessment, activities, plenaries, that type of stuff. So this harks back to one of our previous sessions where we talked a bit about command words and blooms. Have a go at state, describe, explain as a lesson starter. The beauty of this is that it's got built-in differentiation, so pupils can choose the level of difficulty, state being generally the more accessible, up to explain, which presents that bit more of a challenge. So how about this as an N5 starter? Grab a post-it notes and have a go at answering 1, 2, or all 3 of the questions. State the purpose of binary, describe the binary numbering system, explain why the binary system is used by computers. Okay, so loads of great answers. Thank you for that. And hopefully from that you can see the difference in the length and the depth of an answer that you need from state to describe to explain. It's really hard to explain why binary is used in just a couple of words. So the answers I would have gone with, for the state, the purpose of binary, to represent integers, to represent whole numbers. Describe binary, something like it uses ones and zeros to represent whole numbers. So it's just adding in that extra bit of detail because it's a describe question. It's not just 1 or 2 words. It's going into that extra wee bit of depth. And then why we use binary, it matches with the on-off switches inside the computer, something along those sorts of lines. But I think your answers are much better than anything that I would have come up with. You could do something similar for higher. So again, state, describe, explain. This time, state the name of one line on the control bus, describe the role of the control bus during this fetch execute cycle, and explain the steps of a memory read operation with reference to the bus structure. So again, I'll give you a wee chance to grab a post-it note and have a go at these ones, and then we'll check back in on answers in a couple of minutes. Okay. So again, just that extra kind of level of detail that you need as you move from state to describe to explain. So loads of good answers. My answers, I would have gone with, well, you could go with any of the 5 lines on the control bus: read, write, clock, reset, interrupt. Question 2, the role of the control bus. It sends the read signal, or it activates the read line, something along those lines. And then for question 3, the steps of the memory read operation with reference to the bus structure. I use the acronym ABCDE. So AB for your address bus to identify the memory location, C for your control bus, sending that read signal, D for your data bus that sends the data from memory to the processor, and E because the instruction is decoded and executed. That's the way I remember it, which gives me something to fall back on. And again, this might just be a quick starter at the start of your lesson while kids are coming in and logging on and taking off their jackets and stuff. But all 3 of these higher questions could quite easily appear in a prelim or in an SQA exam. In fact, if you are marking the 2025 question paper as we speak, then the question this year was state how the processor makes use of the control bus during the fetch execute cycle. So starters don't just need to be a filler task to get people busy. It could be by putting in these command words that you can provide that sort of vital exam preparation. This type of starter could be applied to just about anything that needs to be covered in computer systems. And again, as you've seen with a lot of the strategies, it could be used for kind of any other part of the NQ course as well. So the next bit is just more sort of formative assessment activities. There's a kind of whole sort of mixed bag in here that are really designed just to engage and as well as assess your pupils' knowledge of computer systems stuff. And again, the focus really is on N5 and higher content, but there's nothing from stopping you putting some of these kind of activities into an S1 or an S2 computer systems unit. In fact, I know of a school that uses baseball caps and table tennis bats to represent binary as their P7 induction lesson. So, you know, it's never too young to start them. If you don't want to go down the hats and bats route, then it's quite an easy activity just to set up with whiteboards. So you get the pupils to work in groups, ideally groups of 4, 6 or 8, and they write the place values 1, 2, 4, 8, 16 on the wall or the board or the window, and then each member of the team stands under one of those place values with their whiteboard and holds up either a 1 or a 0. And working as a team, they have to represent the number that you've given them. You can make it competitive by having a binary shootout. So have a list of numbers and then say 1, 2, 3, go, reveal the number, and the team that can make that number in binary first wins, and the other team are out, and you could do it as a sort of last team standing. Whiteboards, show me boards, and formative assessment, they go hand in hand. If you've read any of the Bruce Robertson stuff, Teaching the Delusion, then you'll know all about that. Binary, floating point, two's complement, naming vector objects, naming attributes of vector objects, anything like that can quite easily be answered with a wee quick show me board, just as a knowledge check. Sticking with that kind of binary theme, many of you have tried some sort of version of binary bingo. There's loads of online resources out there that you can download and you can print out. Alternatively, you can make your own binary bingo cards. There's loads of online binary games as well. So the Cisco one, there's a link for it there. It's quite good. There's plenty of Bluekits and Kahoots and quizzes that you can use. You can make up your own, you can adapt things that are there. AI is really good. So you just ask AI to give you a battery of binary questions and it'll do all the kind of hard work for you. And you can use those questions in any number of different ways that you want in terms of formative assessment. At higher, rather than just focus on binary, why not try a floating point relay race? The first person in the team comes and collects a question, answers it either individually or taking it back to the group, and then the next person comes out for the next question. The only downside to that is that it can be quite frantic. People tend to get quite competitive with it. So sometimes quite good to have assistants that do the marking for you. And it's definitely one that I would keep for a Friday afternoon. As I say, it can get quite tense with the competitiveness of your teams. One retrieval practice or task that can work quite well is an escape room. There's loads of different ways that you can run escape rooms in class. There's loads of different templates that you can get online. The way I've done it in the past is to have 6 rooms in the escape room, and each room has got 4 multiple choice questions per room, and a team only escapes onto the next room to get the next set of questions if they come up with the correct combination of A, B, C's and D's for that words, or for that room, sorry. So in other words, basically the team had to get 4 multiple choice questions correct to then get the next set of multiple choice questions. And again, AI can be really good at helping you come up with the questions or come up with the answers or come up with the kind of distractors for your escape room as well. If you're teaching the kind of security side of things, then STACS have come up with some really good sort of security and encryption resources and tasks. So what you can do is you can encrypt messages. The messages could be about anything, but you could keep them systems related if you wanted, and then get the class to decode those secret messages. Again, you can make it competitive. You can have a race. They can come up with their own appropriate messages for partners to decrypt. There's loads of different examples. Here's just a few of them. Some of the ones that kind of STACS have come up with. So you've got Morse codes. Each letter is replaced by a sequence of dots and dashes. Quite old school, but they might recognize it. Number replacement. So each number in the alphabet is represented by a number. So A is 1 and Z is 26, and you use those number sequences to create your letters and your words. A keypad cipher, again, quite kind of old school. It's like old school text messaging if you're of a particular vintage. So for the young people these days, if you have to make the letter H, you're going to press the number 4 twice. To get the letter Z, you need to press the number 9 4 times. How did our thumbs survive back in the day? There's loads of other examples. There's Caesar ciphers, there's keyword encryptions, there's pig pens. In the slides that I took these kind of screenshots from, they're all in the swag bag, but you can also find them as part of the kind of STACS resources from a couple of years ago as well. As mentioned earlier, Blooket, Kahoot, quizzes, they can be really good ways to kind of finish off a lesson as like a plenary. There's loads of different plenary ideas that you can just adapt to the systems unit. What can be quite good is a couple of rounds of here's the answer, what's the question? So you're giving them an answer, like turn down the screen brightness, and you're asking the class to come up with, well, what's the question that matches that answer? So at N5, that would be something like, how can you reduce the energy, or what ways can you get computers to use less energy? It can also be quite a good way to focus on the command words with the pupils, so encourage them to create the questions that don't have question marks and kind of model those sort of states and explains and describes. So in the kind of ideal world, the answer to this question would be, or the question for this answer would be, state one way to reduce the energy use of a computer. The answer that you give the class might generate more than one possible question. So for example, if your answer was negative 128, then that could be a 2's complement conversion type question. So convert negative 128 using 8-bit 2's complement. Or it could be a question about a range of 2's complement values, like what would be the largest positive integer you could represent if the largest negative integer was negative 128. So that you then get this kind of variety of answers in your class. Everyone loves an odd one out, a bit like the Bridge of Lies earlier. So you can give them 4 statements or 4 answers. You can ask pupils to identify which one is the odd one out. So for example, with this one, we've got increase the data bus width, increase the number of cores, increase cache, increase fan speed. And again, a question like that provides a bit of differentiation. The pupil might be able to identify that D is the odd one out, but can they explain why? And it goes back to those kind of PI questions from earlier. It's all about the why. Can you actually explain why it's not a way to improve computer performance? And the follow-up question might then be, well, what would be another way of increasing computer performance? Which, of course, your answer would be increase the clock speed. If you've got a class that likes a bit of competition, then why not try something like win, lose, bet? You can either set the questions or ask pupils to come up with questions for each other. And basically how it works is each question is worth 5 points. A team can bet a number of points depending on their level of confidence answering the question. If they get the question correct, they keep the points that they bet. And if they're wrong, they lose those points. And the winning team is the team with the highest total points or bets at the end. So hopefully from that, there's a few new ideas to add into your collection. Most, if not all, could be adapted or applied to any of the other areas of the course. All the starter ideas could be plenaries and vice versa. In the swag bag, you're going to get examples and templates that you're more than welcome to use. That win, lose, bet is there. And again, it's something that you can kind of adapt for yourself. You could use these when you're actually delivering the systems content. You could use them as revision after, weeks after, months after completing the teaching. You could use it as prep for part of your prelim revision or final exam revision. And I'm sure you'll have loads of your own ideas or activities that you like to use in your teaching. So it'd be really good if you could share some of those on a post-it during the feedback at the end of this session, or if you wanted to post them on STACS Connected as a way of everybody getting new ideas and new kind of activities that they can use with our classes. So it's goodbye from me, and it's over to Michelle, who's going to focus on some of the SDD stuff.